got you off screen.
That's the only bit of applause I've got to get this evening.
That's the capital for.
Am I good to go?
Yeah. Yes. Apart from the machine.
That's it, right. Well, first of all, thanks for turning out. To get almost 30 people here, or 30 people here, is a bit of a surprise, but it's really welcome. We've just been up the hill and we've looked at things in the field, and so a lot of it kind of made sense in one way, in that we could look at the reality, and now I'm going to try and explain some of that in a PowerPoint presentation to talk to you about it slightly more comfortably. You're not going to be out of breath or rushing or getting wet feet or all the things we were doing just now. People did ask questions as we went this early on, and I actually don't mind if you do, but given that we might overrun, I suspect it might be easier unless you don't understand something and it matters to you, that we keep questions to the end. That way there'll be some flow and we won't go home at 11 o'clock. Is that okay? But if you're really struggling, no, look, there's a complete non sequitur. I've not followed that at all. Raise your hand and we'll do it. So now it's gone all quiet, and I'm the only one without a cup of coffee. So this is what we're going to do. A little bit about me, why I've got every right or any right to stand in front of you. I have to sit. Do you mind me sitting? No. Sure, because if I stand, I'll stand there, and then you'll get annoyed. A bit about time and place. For some people who've been to a talk I've given before, they're just going to yawn when I do this because they've heard it. And then a bit about what the rocks around us tell us about the way things were in the past around here. We've touched on that. Talk quite a bit about the Ice Age, because it's the thing that left most impact on what you see, but it's not something you always associate with geology. It's not the bedrock, it's the soft stuff on the surface. And then just try and explain, where are these maps? How geologists make sense of what we've just seen in the field. So what the world looks like on a geological map. It looks pretty, but it isn't necessarily always fact. And then a little bit, because I think it's important to understand how these rocks contributed to the economy and the social structure of this part of the world. Not just today, but in past societies as well. So by that, I could go back to the Paleolithic, but we'll probably start somewhere in the Neolithic and definitely focus on the Romans. And then, the questions and discussions, then it's your turn. And somebody said, I've got a stupid question. Well, you haven't. There aren't any such things, so just ask it. It's probably one of the best questions we'll get asked if you think it's silly. So, this is me. For 20 years I had an honest job as a field geologist, and then I climbed the greasy pole and went into management and was a director of EGS, and then I got asked to lead a global project to put all the world's geological data and maps on the web. And then in retirement I became a writer of rock books, although I never intended to be, but that's what happened. So that's in a minute, that's me. Now that's my credentials for talking to you, so a pointer doesn't work on a screen. So the first bit is when I was honest. I spent 18 years as a field geologist in the north of England, which is partially what we were talking about when we were out in the field. So time and place, forgive me those of you used to this and that, we've been doing analogies a lot. We've been punishing GPs on our way around, but general practitioners. But I'm going to use a different analogy now. I'm going to use a toilet roll, and if we had the time, I'd go grab one from Elaine's toilet and bring it in, and I'm going to adjust your GPS as well. So here's a toilet roll with 150 sheets of paper, because you're going to Waitrose, you haven't gone to Aldi. good stuff this. And that 150 sheets is, if we use it as the age of the Earth, 4.5 billion years, 4.62 if you want to be difficult. Billion. 4,600 million. And we're going to be talking about sheet 11. And just so you know how important we all are, we're just a little perforation at the end of the last sheet. That's how significant humankind is. The Ice Age started about a few millimetres in, and the Carboniferous, the rocks around here, 330 million years, that's sheet 11. And all the rest of that toilet roll, and we could have fun unrolling it here. And it would go a long way around this room twice over, and you still wouldn't come to the age of the Earth. So if I do that a different way, because I haven't got the toilet roll, if I stand up and my body plus the arm and the fingers is proportionate to 4.6 billion years, we're talking about my wrist today. That's the Carboniferous. And if I talk about humans, I've just rubbed it off. It isn't even the scraping at the end of my fingernail. So consider just how significant we really are in the shape of things. If we hadn't stopped the next ice age, it would have neatly cleaned everything up we've made a mess of. So bear that in mind in terms of time, because these are big things that, you know, if you ever listen to astronomy programs and they talk about how far away the sun is and how many galaxies there are in the universe, you get the sense of, I can't cope with that. But I guess those astronomers will. Well, guess what? They can't. They can't compute. And nor can geologists compute time. We're just used to talking about it. But it hurts our heads when we think about it. It's almost beyond comprehension. So we're going to talk about two things. This is a conventional geological timescale. You probably, if you did geology or geography at school, you might have dipped into this. You've certainly heard of the Jurassic film, Jurassic Park. But we've been in the Carboniferous, and we've seen the Ice Age. That's the Quaternary. So we're going to talk about those two things. It's not that none of these rocks didn't exist here. These ones all exist underneath us, just a few kilometres down. And these ones did it. Well, if you come from Cumbria, if you're from Penrith, you live on that stuff. If you're from Wetherell, you live on this stuff. From Castle Carrick, you also live on this stuff. But these here, Jurassic and Cretaceous, were once here. Chalk was over everything, but it's all gone. It's all been eroded away. But we've had 150 million years to erode it all. It's quite possible. So let's talk about place. You're very used to putting your finger on a globe like this and saying, I'm from here, 55 degrees north, I know exactly where I am. Well, this is where we were in the Carboniferous, pretty much on the equator. So please bear that in mind when we talk about things in the past, because it's a bit hotter on the equator than it is at 55 degrees north. And some of the things, the changes in the rocks, are because we've migrated. Actually, we were once down here in the Ordovician, and we were about there 450 million years ago, and then we just went like this. A little wander around the globe. That's what our bit of the planet has been doing. But we didn't look like Britain then. We were just a bit in the middle of a continent or under a sea. So the next bit of the refresher on geology is three sorts of rocks. There are igneous rocks, and there are sedimentary rocks, and there are metamorphic rocks. And an igneous rock is a rock that was once molten. And a sedimentary rock was a rock that was once sediment. And a metamorphic rock is simply a rock that's been changed by heat or pressure, and once was igneous or sedimentary, but it got a bit messed up and gnarled. So slates are metamorphic rocks, and gneisses are metamorphic rocks, and schists are metamorphic rocks. So they were just once one of these two. And just, you do me a big favour here, especially if those of you who are about to do archaeology. This is me. I want you to know that an igneous rock can be volcanic or it can be intrusive. But you can't say volcanic for the Windsill because it was an intrusion. I'll come on to that later. That's the equivalent of me standing in front of an archaeological audience and saying, the wall was built by Septimius Severus. No, it wasn't. It was built by Hadrian. Do I care? He's just an emperor. And that's how important it is when any archaeologist says the Windsill was volcanic. So I get touchy about it. Very touchy. And I'm about to get more touchy. But we're going to talk about sedimentary rocks, because that's mostly what's here. So we've seen a sedimentary rock. I've knocked a chip off a block up there, and that's what they look like in the field. And that's the sort of environment it was at the time. Lots of big rivers, lots of sand, gravel, running through forests, tropical forests, because we were at the equator. And we've got coal here too. You know, coal looks like black stuff. And that's what coal used to look like. It was once plants, vegetable matter, and then it became peat and it decomposed and it got compressed, and then it got compressed and aged millions of years, and it became coal. So we used to look like a coal swamp here, several times over. And we've got shale, more correctly known as mudstone or claystone. That's shale up in one of the valleys over to Durham. And this is what shale was as an environment. It was just a mud bank, or a lagoon, or a brackish water. So in simple terms, we've got those three sedimentary rocks, and they all occur here in layers. Oh, we've got limestone, forgot about that. That was, you see those nice wavy beds. Limestone was when this part of the world was a coral sea, or multiple coral seas, time and time again. So we didn't have a yacht in the Carboniferous, but that's how we looked just then, like the Bahamas. And the way this works is that those environments are all a product of rising and falling sea levels. So as the sea level falls, we get rivers braiding out, and we get coal swamps forming, and then the sea level rises, and we get limestone, 200-metre sea depths, and we know how deep the sea was because there are fossils in there that require light and a reasonable amount of oxygen. So we know about the maximum depth of the sea. We also know it was pure, because corals don't like dirty water. So, and then the sea level fell, and we get mud banks and estuaries and lagoons, and we get mudstone and sandstone, and so it goes on. Sometimes it isn't complete, and that's why you get the different layers of rock. The sandstone, the limestone, the shale, the coal. That's how it builds up. Does that make more sense than me waving my arms around on the fell side?
Definitely.
It does. Thank you for that. Yeah, nothing like a confidence boost, is there? So every different environment produces a different rock type. And in a sense, what we do is, geologists do, is the way they understand things is they go to places that have these environments today to test, is that how our rocks were made? So it gives us a nice business class ticket to go to interesting parts of the world like Brunei or Malaysia to look at big rivers and coral seas and swamps, or to go to the Arctic or the Antarctic to go and see how glaciers behaved. So it's reasonable, isn't it? You know, I need to see how this works. So back to the three rocks, and I wanted to cover igneous, and I'm not going to do volcanic again because we've laboured that point. But there's a very famous igneous rock, a once molten rock called the Windsill. That's what it looks like in Gilderdale stream up there. It's quite hard, so it forms a set of waterfalls and a set of cascades. It's really pretty. And that's what it looks like in your hand. And this one, if you put it under a microscope and you turn it through polarized light, then all the minerals have a different color signature. And they also, as you turn them through polarized light, they have a different extinction point. So you can tell what the mineral is. Orgite, pyroxene, feldspar, quartz, by turning them. And that's what you spend your time doing for almost a year at university until you're sick of looking down a microscope. And then you never use it again because you've got this guy, specialist petrologist, who loves doing that stuff, and you send him the rock. So that's what the windsill. But you know, there's a lot of windsill about, and you probably want to know what happened to it, where it came from. Well, it's about 295 million years old, so it's younger than the Carboniferous. So it's younger than the Carboniferous, but it's within the Carboniferous. So it isn't a volcano, so it can't be volcanic. It's intruded. A bit like putting the jam in a vanilla sponge as an afterthought. You forgot it. It was at the start of a period called the Permian, when we were in the middle of a huge continent and a desert. And we looked a bit like that then. And yes, we did have these things. And in fact, there's a couple of tetrapods, because that's about as much as we know. We know they have 4 legs and 4 feet. A couple of foot slabs from Penrith Sandstone in Tully House Museum of animals like this from this time lived around here. So that's a really crude drawing, that first bit, of what the windsill looks like. Forgive but you know that it's on the wall and it goes up through Barrisford, and you've seen it at sea houses and Bamborough Castle, so you know it is. But you're just looking at the tip of the iceberg, if I can use that analogy. This is how big it really is, because it goes underground. No, it won't work, will you? It's going to be difficult. There you go. 4,500 square kilometres. The biggest igneous intrusion in England. It goes all the way under dirt. Well, you know that. High force, low force. You've seen all those places. Coptail, Laccolith. All of those. And it's all continuous. So it's enormous. And most people just think, they see the tip of it and think that's where it is, but it's really big. So how did it get to look like it does? I'm going to choose the Roman wall as my place. So there's a big magma chamber several kilometres down. Besides, the real reason is the Earth at that time was under tension where we were living, and it was pulling apart. And when a minute it pulled apart, this magma chamber full of 1100 degree molten rock decided, opportunity to get to the surface. Up it goes, spreads out, intrudes along weaknesses between the rock layers. Still doesn't look much like the windsill, does it? So there it is. And although we don't have many earthquakes today, we used to be in fault zones and mountain zones, and things get broken up. So we'll break the wind up a bit. Still doesn't look like the windsill we see. Let's tip it up a bit. And then 295 million years of erosion later, can you see a cross-section of what the windsill looks like? You're coming across the A69, you're looking east, you're going back to God's own country. I can't say that, I'm from Carlisle, but you know what I mean. You're looking into Northumberland, you're yet to descend into Greenhead, you see this beautiful scarp and dips caused by the windsill. That's the profile you see. And now you understand how this molten rock 295 million years ago could turn into the Roman landscape wall country that you know well. So we're now going to jump from, thank you very much, there's no way I can drink that and talk at the same time, I can't multitask. So we've been here, and we're going to go on this little bit. So we're literally almost at the white bit of your fingernail. What have we got to talk about now? The last 20,000 years ago. So 20,000 years ago, the South Tyne Valley did not look like this. As pretty as your farm looks. It didn't look like that either. You're going to be shocked. That's what it looked like. all over. All the way down to York, to Manchester. Don't know why it didn't cover Manchester. North Wales. And max thickness maybe 1,000 metres. 3,000 feet of ice. And it covered everything. And of course there was an undulating surface underneath it of the rock and the pre-glacial surface. But we've been glaciated several times before, over 2.6 million years. And every time we've been glaciated, then the Earth's warmed up again, and we have what's called an interglacial, a period with no glaciation. And that's what we're living in now. We're living in a period, a warm period, except, as I explained to people when we went for the walk, we've kind of screwed it up. So we would have had a cold period, we would have had a glaciation in about 50 to 70,000 years. We'd have looked like that again. And all the mess we've made of the planet, nature would have neatly just scraped it all off. But we've overheated the planet, and the current thinking is that we've put off the next glaciation. And you might well start to cheer now and say, well, that's a good thing, isn't it? Except, as the people who went on the walk know, what we've got instead is extreme weather, extreme temperatures, extreme flooding, extreme winds, and we'll have to deal with that. And sea level rises that are probably at the upper limit, if not beyond the upper limit of most scientific predictions at the moment. So all those people who denied it for the last 20 years, as I said before, scientists are fairly moderate people. They don't like to give extreme predictions. And they're very cautious, and they don't like to say things that might be regarded as sensationalist. But as we speak, most of the predictions for climate warming and sea level rise are now at the upper end of all their predictions. So it isn't us that are probably going to suffer too much, although the weather's definitely changing for when it's different. And it probably isn't our children, but our grandchildren will see that. And we'll see flooding and see extremes of temperature. And I was in Oregon seeing our kids 3 weeks ago, and we had to stay indoors for 2 days because the air quality index was so high because of forest fires burning in the area that we couldn't go out. And that's adults couldn't go out, not just children or the infirm. So I think we live in interesting times, I think, and there's still time to drag it back. But whether politicians will pay enough attention to the EE environment and less attention to the EE economy, I very much doubt. And you can point the finger at them all you like, but we voted them in. And we won't hold their backsides to the fire when they don't deliver on things. We seldom do. So just blame all of us. Right, let's be cheerful. So this is the job I used to do, trying to put the map of the world together on the web. And so this is what one version of it looked like. But can you see Britain on that map? Do you recognise it, even though it's full of... All the pretty colours are rocks. Geologists... Somebody experimented initially by trying to make a geological map look at the same colours as the rocks did. And the rock was all grey and brown. So there was a guy called William Smith in the late 18th century who defined, really, he was an Englishman, who defined the colours that I've usually stuck to for most rocks. We're there, for those of you who just said, yeah, I know where we are. That's Scandinavia. And this is the mid-Atlantic ridge. And the reason it looks like it does, these different colour bands, is that there's molten rock coming out of there. And this is like a conveyor belt going two ways. The Earth's splitting on plate boundaries, it's going like this. So every bit out here is older than this bit. And then these old bits, this is Africa, and this is Europe and us. And then you get round here, well, there's the Rift Valley here. And if we'd got far enough down to New Zealand and Australia or around the Pacific, the reason why we don't have many earthquakes is we're on this big, stable part of plate, tectonic plate. So we're well away from all of the, well, you can see poor old Iceland up here. It's suffering volcanic eruptions at the moment. So it's a geologically very active place, and we're a geologically very inactive place. I think we had one earthquake in something like 1736 in Colchester that injured somebody by a tile falling off the roof. But it still doesn't stop the media getting really excited and phoning my old organisation when we get an earthquake of 4.3 in Wales and saying, what happened? My lollipop fell off its stick. So it's not likely to be a problem. So we're coming a bit closer. There's us, and a bit closer still. So we're getting an increase in resolution, and I recognise Alston. And there's Elaine's farm, and there's the most detailed map. And that's where the people who were fit as fiddles, we walked from down here, up through the fall, along there, we crossed a fault, a tectonic fault, didn't tell you about that. And then we walked up the stream, and we saw the Great Limestone, GL, and then we saw a couple of old levels, and then we walked up through a field gate here, through this gate, and then you got your feet wet, and you thought, why is he plunging us through here? Because I wanted you to see these old mine drifts, adits, into this dotted line here, which is the little limestone coal. So it's really hard. This is looking at a plan, and all of these are the oldest rocks. And if you would look at a section, you'd see it go. So these are all horizontal layers, but I'm looking at them in plan. It's a bit tough, really, to expect you to see this thing in 3 dimensions, but you sort of get it. Yeah. Okay. So that's the actual geological map at 1 to 10,000 that was mapped in 1965, 1970. So in limestone and sandstone and also the deposits of the last glaciation. So if I simplify it, there's Epiacum, there's the limestones, there's the sandstones, there's the coals, there's the faults, there's the boulder clay, the glacial stuff, there's the mines, coal mines, and there's the trials for lead. So you saw all that, and it was as plain as the nose on your face, wasn't it? And doesn't it look, now you see it all up in PowerPoint, must be fact. And yet, how many rocks did you see today? But that's the best interpretation we have. And for all those maps of Europe, Britain, the world, they're all subject to the same amount of tech. They all have a big confidence bar on them. So to move on to maybe the best bit, the bit where you feel more comfortable really, is how have we put these rocks to use? I could put it another way, how have you lived without them? And why have you paid geologists more? Because without them you wouldn't have houses to live in, or walls, stone for your walls, or stone for your monuments, as the Romans found. They get into the most mundane items. So before IKEA, this is for people who were born post 1970. Before IKEA, your dad had a whetstone in his shed, and he used to go sharp. And if you didn't, you used the side of the mantelpiece before you had your Sunday dinner, because he had to sharpen the blade of the knife. Whetstones were in everybody's house, and we don't even think of them now. They were absolutely essential until about, I guess, 1950. Well, people used to come around my street and knife sharpeners, but before that, everybody for their edge tools had a whetstone. Just want to know, that's a bit of geology you're using there. So. These you know very well, and somebody's put some querns, or millstones we call them, on the back table. These are Roman millstones. These are the ones in the sandstone, mostly. And they're mostly local. And many of them, I guess, might come from the hills around here. But some of those stones, that one there, is not sandstone, It's volcanic. This is where an archaeologist can actually use the word in the correct form. It comes all the way from the Eifel volcanic region in Germany, and it's called a Mayan quernstone. And the people from Tongeren, which is the first cohort of Tongerens, who were garrisoned on several forts on the wall, they brought those quernstones from Eifel with them. And if you go to Tongeren, you'll find that the only quernstones they have are ones from Eifel. And the reason they like them so much, quite apart from because when they're suddenly garrisoned here, they don't know whether the natives will have anything as sophisticated as a millstone or a grindstone. The reason they like these ones so much is they're made of a volcanic rock like a basalt. And the basalt was very frothy when it erupted on the surface. It had lots of air bubbles, microscopic air bubbles. And and it's very light because of that, so that's helpful. Otherwise, these things weigh 20 odd kilos. Can you imagine packing these with your cohort? The reason they love them is that those microscopic bubbles, when you rub one quernstone on another, the edges of the bubble self-sharpen. So they provide and what's more, they don't put as much sand and grit in your. Ever wondered why ancient peoples have such poor molars? Because they're used to eating rubbish flour, that's why. Because it's not ground well. So, limestone, everywhere, every square kilometre, especially this part of the world. Little kilns. This one is a big one at Crindledykes, and it's 18th, 19th century, I guess. Limestone, it's CaCO3, calcium carbonate. You chop it up, break it up, you load it into the top of the kiln, you layer it with coal, or charcoal, or timber, and then you set light to it, and then this pot here, you rake out the calcium oxide out the bottom, because you burn it, so it burns off the carbon dioxide, and you're left with calcium oxide at the bottom. And then you wet it, and that makes quicklime. And then you dry that, and then it makes the material for lime mortar, but it also makes lime for making the soil on very acidic ground. It makes it lighter and more fertile. So these lime kilns were everywhere, and mostly they were for agriculture, but they would give a sack for somebody who wanted to make lime mortar to put in their walls. Coal. Well, we spent a lot of time up the hill discussing the little limestone seam and how it was used and is used right up to today. But coal's a pretty common mineral in these parts of the world, and there's one seam that's called the little limestone coal that's exploited everywhere. People in the past have used coal. We definitely know that the monasteries in the 13th century were using coal. And we also know that the Romans used coal because there were coal bunkers at Houstead's Fort in the East Gate, and at Benwell, at fort whose name I can never remember. That has they found an enormous coal store there, and there's an argument, but the Romans may well have mined coal on the site, because Benwell is in the Northumberland and Durham coalfields, so you have 23 or more mined seams under the site. So the Romans, and one of the little side stories here, the Romans, everybody thinks intuitively, geologists and archaeologists, that the Romans mined the coal near the wall, but the only piece of provenance testing that has been done on coal from Houstead's, Vindelander and Corbridge, I think, maybe Chester's, is that it came from somewhere near Ebchester in Durham. Because coal is one of the few things we can provenance with some degree of certainty because of the little plant spores that are in it. So they're not pollen, because tree ferns didn't produce pollen, but they produce spores. And the other thing we can do with coal is what's called its maturity. So we look at its vitrinite reflectance and we can say how old it is. So knowing which layer it is gives us a clue about where it came from. So right at this minute, because of the uncertain nature of where the Roman coal on the wall came from, there's a proposal for a research project to try and re-examine some of those codes to see whether they actually are local or whether they've come all the way. I mean, you might think this is a pretty stupid point, but think about it. If that coal is coming all the way from Durham, 35 kilometres from, say, Ebchester, or is the quartermaster just buying it locally? Think of the social and political and military narrative that alters by simply thinking about where that material came from. Think of the story it might tell. Right at the moment, they think they just brought it from Durham. Well, who says? What's the evidence? Is that statistically valid? 5 samples doesn't seem any good to me. Give me 500, I might believe you. But we're about to find out if somebody puts their hand in the pocket, because we can do the lab testing. Here's another contentious subject for archaeologists anyway, not just Roman ones. So iron was in big use by the Romans and obviously by the Iron Age people before that. And there's a lot of it used. They couldn't melt iron because it's got too high a melting temperature and they have no technology for it. So what they did is put it in things called bloomeries and heat it up with slag, and then they hit it with a hammer, and then the impurities come out in the slag, and they're left with a lump of iron that they can then mould and make into weapons or suits of armour or pots and pans. The received wisdom in all the archaeological papers is they got their iron from what's called bog ore. So if you've ever seen, you've been up on the fell, you've seen all this orange stuff come out, or you've been to a coal mine somewhere in Durham, you've seen this orange seepage come out, and that's iron oxide, and it gathers and blooms around things in mosses and peats. And that is bog ore. And the theory is that that's what Iron Age people and the Romans used. No? And when you say, well, can you take me to a place where they mine bog ore? Oh, well, you don't see them anymore, we've drained all the fields. Well, that's very convenient. So where's your evidence? And especially given that 300 metres from, say, Vindolanda is a geological ore, bedrock ore, called siderite. That's one of the nodules. You can see them in the meander scar if you go to the footpath down there. And you can see 18th and 19th century ironstone workings. And we're not short of this stuff. Shotley Bridge, Concert, at Lanchester Fort, a Roman fort, sits on coal and iron ore like this. You go to Bellingham, up the North Tyne Valley. There are iron mines that worked there that provided the iron and built some of the bridges over the time. We're not short of iron ore. Go round to West Cumbria, you've got a rock called hematite, an iron ore called hematite. That was the basis of Southwest Cumbria's industry for 100 years or more. It was massive. But what's more, hematite is bright red and stands out in the soil and in any gully. It's as obvious as the nose on your face, just as these are. If I threw one of these at you now, you'd go like that, because its specific gravity is so high. Immediately you know you're dealing with iron. So there are all these geological sources of ore, and yet the archaeological literature says they came from bog ore. Where is it? Prove it to me. I'm not saying it isn't plausible, but without actually definitively proving it, you must have the word, we tentatively think that. They used go into a museum, and if you go, Bronze Age, bronze, by the way, is copper and tin, and brass is copper and zinc, and gunmetals, copper and zinc and brass, or all of them have a bit of lead in. But go into every museum, and the stuff you'll find from the Bronze Age are now described as copper alloys. They don't say bronze anymore. And so the question is, where did the copper come from? Well, the only known Roman copper mines, the nearest ones, are in Alderley Edge in Cheshire. Some people from Cheshire here. I just wanted to make them feel warm and comfortable by getting a mention. So Copper occurs around here too, in a mineral called chalcopyrite that occurs in association with the lead, and you can take copper out of things. We've got zinc as well, and the Romans obviously used zinc in brass, but they didn't know they were. I mean, they knew they were, but they didn't know how they got it, because zinc's got to a higher melting point. It just came in with the other minerals. But they make all of those museum things have got artifacts, and you'll see them from medical instruments to pots and pans to jewellery and ornaments, and they come from copper. And the question is, so where did the copper come from? And we don't know. We don't know whether it was a tradable commodity that was coming up from Cheshire or elsewhere in the Roman Empire. Or was it coming from the Lake District, or was it coming from the Pennines, or was it coming from Scotch Corner? Believe it or not, one of the richest copper deposits in the whole of Britain is in a place called Middleton Tyres, just near Scotch Corner. And those of you who are archaeologically minded know that a place called Stannock, which is an Iron Age oppidum, a big Roman fortress and centre, is only a couple of miles from that as well. Is that a coincidence? Was the copper there the attraction for those people or not? I don't know. But the question that bugs a geologist, if you like, is, yeah, this is very nice, and I want to know what the religion was and all this other sociological stuff. But for me, it's, where did it come from? You know, you can see the autism of geologists. Where's it? Where is it? You know, how do you know? What stories does it tell? And these are open questions. I'm going to claim tiles and clay as geological too. I mean, that's an old picture from early part of the 19th century, early part of the 20th century, late part of the 19th. It's a clay pit in Botcherby in Carlisle, one of many. And if you go down the A6, and you go down the A6, the old A6 from Carlisle, and you don't go very far, you'll come to a place where there are 24 Roman kilns, Roman clay tile kilns, and they were seemingly providing tiles, roof tiles, to house Carlisle. And I guess in most excavations in Carlisle, they'll come across these tiles, and they're made of a glacial clay that's stone free. And the amazing thing is the Romans or the societies that came before them knew where this limited amount of glacial clay was that didn't have stones in it, that was absolutely perfect for cutting up, moulding and making tile. Stones are a bugger when you make in ceramics, because they differentially heat things and break. This clay tile's got a story to it. This is the 9th Legion. Do you remember the Eagle of the 9th? This is the famous legion that were based here making tiles in Carlisle, and ultimately got lost. So there's a lovely story about it. But you can find Scale Scuff is the place. You don't see much of the kilns now or the clay pits. It's just a humpy grass field. But if you go into the little stream, the River Petrel, near it, then you can come across the clay that they were using. So we get more obscure geologically. Are you bored yet? Yeah. So this is a rock called tufa, of which Elaine had a piece in her wall, and she looked completely uninterested when I said that's really, really, really interesting. So
in the end of the day, wasn't it?
Yeah. It was the end of the day, and I'd gone on for a long time. So tufa is a really critical rock for the Romans. I'll explain why. But first of all, tufa, like that block on the left, which is just near Newbrough, and Newbrough's a little place near Four Stones on the Staingate in Northumberland. You might know it. Anyway, tufa is calcium carbonate, but it's modern calcium carbonate. So have you been to Mother Shipman's well, the dropping well? You know what that is, don't you? You get water coming out, like up there, the Great Limestone. It's rich in CaCO3. Immediately it comes out, it releases pressure, so it degasses and then precipitates calcium carbonate. And so all tufas are less than 10,000 years old. They all post-date the last ice age. Tufa, T-U-F-A, not to be confused with tuff, T-U-F-F. Tuff is a volcanic rock that has similar properties, but it's not a sedimentary rock. Yet another little minor tick mark or cross mark in most archaeological papers, because they conflate the two, with good reason. You know, they both perform the same function. So that's tufa. And if you looked at a geological map, you wouldn't, of the north of England, you won't find much tufa, because usually it occurs less than 10 metres by 10 metres, and we didn't map anything bigger than 10 metres by 10 metres. So it's rare to find it. But why is it interesting? Well, these things are from Chester's. This is Chester's bathhouse. Can you see them all right? They look like that, don't they? They're like a rectangle that's got notches there and a notch there. They've got the lovely name, armchair voussoirs. And they're made of tufa by choice, because the specification for a Roman bathhouse, and you must have seen Chester's, it's big, and Roman bathhouse was set out by a guy called Vitruvius in the 1st century BC. Yes, they had a specification for everything. And he said, I want you to build this bathhouse, it has to have underfloor heating, and then I want you to make the walls cavity walls, because I want the warm air to go up the sides. And when we come to the roof, I want it to be an arched roof. And I'd like you to put these voussoirs, like that, arch stones, all the way across, but not all over, just in ribs like this, and then notch them, and then put one of those clay tiles between the notches to create a cavity. So you've got warm air going under, up, round. What's more, this stuff is super light. This is like nature's thermal block, lightweight block. So, mostly you find tufa on an archaeological discard pile. That's the place where they dump stuff they don't think is important. Because it's a bit of a difficult rock to identify. But it's got this wonderful story. Because if you go into Housesteads, where the bathhouse used to be down in a stream called the Nag Burn to the east, and is now inside the fort, you'll find 3 bits of broken tufa inside the secondary bathhouse. When John Hodgson, the antiquarian who used to live at Ebchester, who started the Society of Antiquities in Newcastle, when he first investigated Housesteads, he found loads of these things in the stream, and they've all gone now. But they tell a story of the Romans building a sophisticated bathhouse to a specification, and even going to the lengths of finding the right rock to build it with. So, okay. Now, where's the guy from Ripon? I didn't know you were coming, but I've got a story for it. So this is a place called Cock Lakes, which is not so far from Weatherly. But down the A6, a little bit, just past the M6 roundabout, junction 42, turn off to the left, near Coat Hill. There's a place called Cock Lakes, and until the 1960s, it was a gypsum mine, pre-British gypsum. So it's just like Kirby Thorpe. This stuff's gypsum. And this stuff's sandstone. There's a bit of glacial deposit, and this is the mine. And they worked it, and most of us know it because of this stuff. Plasterboard, plaster. But it goes in a lot of things. In fact, if you buy your flour from the wrong people, you might find it's been adulterated with a bit of gypsum because we can bulk it out. But the Romans liked gypsum, but we have no idea whether they used it up here, even though you can see that 3 metre seam of it. Here Cock Lakes, and you may be familiar with Longmeg and Longmeg Mine, gypsum mine. So it runs, I know, all around the Whitehaven side as well. But the Romans liked it a lot. They in Pompeii, they had used gypsum crystals called selenite, same CaSO4. They used those as windows. And alabaster, which is another form of gypsum, they carved into beautiful ornaments and things. And in York, so in the 19th century, they found 40 bodies, Roman burials in York. And each of them had undergone a practice that they'd never seen in Britain before. They'd had liquid gypsum or plaster of Paris poured over them, over their burial shroud. And this is a 3D scan, and you can see there's one adult, here's half of another adult, and there's a baby. So and it's not a usual practice, but it does occur elsewhere in the empire, on the continent, in Asia, and they're not quite sure. They think it's probably highborn or elite people who went to this level of ritual burial. But the interesting thing, as ever, not really worried about the poor baby or the rest. The interesting thing for the geologists is where they get the gypsum from. Where were they bringing that from? And were the Romans using it on the wall? And when they plaster, because there's lots of Roman plaster about, is it always lime plaster, or is it some of it calcium sulfate plaster? Do you go test this stuff when you see it? So these are, I'm just biased. I look at everything through a geological lens, I guess. It's really boring, but
there's gypsum at Sherburn and Elmet, not far from you.
That's right, there is. And there's gypsum at Knaresborough. And there's gypsum at Ripon.
Tadcaster.
Yeah, and Tadcaster, yeah. So there's a load near York, but I guess my question is, there's an even more of it up here, and it would have been visible in the side of the valley of the petrol. What did they use it? Or is it a case of misquoting T.S. Eliot? We didn't find it because we didn't look for it. I don't know, but it's about having that view. It's archaeology is about untangling history by looking at human exploitation of things. Geology is about finding where resources are, regardless of not whether we've used them. So, there's a scientific truism, and that is absence of proof is not proof of absence. So, this is just asking questions. We've got these minerals. Who used them? Maybe they didn't. Maybe they didn't at all. But
So is it sedimentary rock, or
Really?
how does it exist in
God. I didn't think anybody would be interested enough to ask that question.
Could you repeat the question, please?
Yeah. The question is gypsum a sedimentary rock? Yes. The answer is, it's not unlike that limestone, except it precipitates out of incredibly salty seas. So think Dead Sea or think Death Valley, and most of the salts are sodium chloride, NaCl, but some of them will be halites, rock salt, and some of them will be calcium sulfate, and some of them will be things that are poshly called polyhalites, which they mine at Bulby. So polyhalite just means multiple salts. Yeah. So think of that part of Cumbria, most of the Carlisle Plain and the Eden Valley, at one time being a big embayment of a salty sea that stretched over the Solway, and it got hot and evaporated, and more salts, and then the sea would flood in, refresh it, and the same happened over in County Durham and in Yorkshire as well. So, you're welcome. So, what else can you do with things around here? Well, you probably know that Roman buildings weren't boring grey-brown sandstone. Actually, they were all, even though we were up in the distant north here, they usually put lime mortar on the walls, and then the higher status the building, the finer the coat of finishing mortar and whitewash distemper. And then they decorated them with pigments, and they've got they've got quite a few plaster fragments from several forts, including Arbea, with pigments. And where do they get their pigments? Well, many of them are from plants, so they're organic, but some of them are inorganic, some of them are mineral derived. And the local link here is if you just go up the fell up there to Horse Edge, on the other side of the Gilderdale Valley, there is an umber mine, and several of the people in Alston, in this parish anyway, if you, around the turn of the century, if you were to look at their occupation in the census, it's umber miners. So umber is just a weathered derivative of ironstone. It's just, it is like rust in many ways, soft rust. But it has umber and ochre are pigments. Also think of copper pigments. You know, azurite gives you blue and malachite gives you green. So you can make most of those colours from minerals, but it could well be that they chose to use plant extracts to make their pigments instead. Right, there are two people here who know all about these. So the Romans and many other people liked jewels, Bronze Iron Age people too. And on the left-hand side, this is jet, and that's usually sourced from the North Yorkshire coast, rarely found anywhere else. This is gold, which is not found here but is in Wales. This is from Corbridge, this thing. And this is lithomarge, which is, you know, to a geologist, it's kaolinite. In other words, it's a feldspar. But lithomarge sounds much nicer. And it was used, both it and jet, both had religious medicinal properties. So lithomarge, this was an amulet found in housesteads, and you would rub it on the bit of your body to make you better. I am gonna resist any medical analogy now. But it's better than antibiotics. These are all intaglio gems, but most people in here who come from the Cumbrian side of the fell know that they were all found in drains in the bathhouse excavation in Carlisle at Eden Bridges. And they're beautifully carved, and they're very small. Some of them are maybe only 3 or 4 millimeters high. But their story is that the bathhouse was hot and warm, and they fell out of the rings because they were set in the vegetable glue. Is that still right? Yeah. There are people who excavate there, so I'm cautious. They're intaglios. What that means, they're reverse carved, and they're signet ring really. You press them in wax, and that's your signature. And there are so many of them that the head man of intaglio rings, called Martin Hennig, thinks that Carlisle might have been a workshop for making intaglios. But as ever, the profane, prosaic question that a man like me asks is, where'd they come from? Where'd they get the rocks from? And I wrote to Martin because you never get anything, and you know, shy Bairn's getting out. So I wrote to him, mailed him, and he answered. And then we had a phone call, and I said, where are they from? He says, I don't know. And I said, but you're the world expert on intaglios. And he said, yeah, I am, but we don't know where they come from. And I have some sympathy with him, because it's not easy to tell where they come from. But the assumption is they come from somewhere away. They come from either the northeast side of the Mediterranean or even further away. To a geologist, these are that word. They're just chalcedony. To a jeweller, goodness me, you wouldn't dare say that. They're jaspers and carnelians and tiger agates. And it's like dealing with a kitchen working surface person. They all call them all granite instead of not. So I said, you know, and so there's a jasper, and this one's a carnelian, and this one's probably an amethyst. These are jaspers too. Not sure what the black one is. But it is possible to find out where they come from. And the way you do that is by some clever atomic level geochemistry. But unfortunately you have to take a little bit of it and the micro-destructive. Well, you can imagine how well that goes down. So, and the other thing is, you need two things to provenance to find out where something comes from. It's easy enough to tell you what this is in atomic. They're all silicates. They're just silica. Just silica. But it's easy enough to tell you what its precise elemental composition is, molecular composition is. But then saying, okay, where does it come from? In the absence of a complete database across the rest of Europe, I'm left with going, does it match with that one? Does it match with this one? Does it match with this one? And so that's the way DNA works, by the way, because we've got these vast databases. So when somebody, if you're convinced enough by Ancestry.com doing your DNA, and I wouldn't bother doing it, then they've got this vast database, so they can say, yeah, you came from there. We haven't got that with so many materials, and certainly not this one. But that would be the way to solve this problem. So there are two big hurdles, really. One is persuading a museum or the archaeologist, please let me drill a very small hole in the back of your gem. And the answer is, not on your Nelly. And the other is, we haven't got the databases. And there's an even more complex problem. I'm getting really academic and nerdy now. But when archaeologists apply for funds to do stuff, and say they'll put some money in to have some isotope work done, the isotope lab will usually say, do you mind giving us a bit more so we could help us build up this reference data set? And then when you ask us the question, where this come from, we can answer it. Oh no, the budget won't stretch to that. So the reference data set never gets built, without which, well, it's a struggle to find out where things from.
With all the silicates, what gives them the different colour? Is that different temperature pressures they've been exposed to, or is it different other minerals mixed in with the silicates that cause the colour?
It's the latter. It's the, I was going to use a rude word, it's the contaminants. Yeah.
Yeah.
It's the other things, other minerals. And to some extent, in terms of jasper, which is cryptocrystalline, but it's you can't see the little edges of the crystals, but they're there, whereas some of the pure ones, they're almost glass-like. So here's saving the best till last. This is what Epiacum is. How are we doing for time? Do you want to go home yet?
No.
Right. So here's galena, lead ore, mined here mined here for centuries, really, and certainly in the 18th and 19th and 20th centuries. And galena is lead sulfide and PBS, and that's that's a pretty version of it, and it occurs in mines that are usually well to the south, 5k to the south of Epiacum. But the reason this story is relevant to Epiacum is that they received wisdom is that Epiacum's location as a fort was about policing the Roman lead mining and silver mining industry here. And the basis for that is there's an awful lot of lead in these hills, and that the Romans used a lot of lead. They used it everywhere. It was their plastic, pipes, slingshots, makeup, eyeliner. No, I don't exaggerate. All of these things they used lead for. They used it for caulking. This is from one of the water tanks at Housesteads. This is Roman lead still in the water tank at Housesteads. And so Epiacum was thought to be maybe one of the reasons for its establishment. It was not just to guard the road that went from Kirby Thor up to the wall, but to police the lead mines. And the amount of evidence, circumstantial, for Romans mining lead is huge, and it's compelling. And I think most people would regard the amount of evidence as being sufficiently substantial as to. But there is a problem. The but is that there is no Roman lead mine. Nobody's ever found a Roman lead mine. Nobody's ever found a Roman object in a lead mine, and at least written it up. So you're left with a murder but no body, really, in one sense. You've got an incredible amount of lead in the North Pennines. Were the Romans here to police state lead mining and make sure the proceeds stayed within the empire? Or were they simply here to guard an important road and stop these unruly barbarians in these hills? Because you know Alston people are going out of control. And it makes for the research opportunities and stories that have been told about lead mining by Romans. But for geologists, the most of the evidence comes from the 19th century mining, which is really well documented. And was an enormous industry. It was the biggest lead mining field in Europe at one time. So, moving on to a really contentious bit, there is also a narrative that says the Romans were here after silver as well. And the problem with that is, just like the problem with lead, although there's no evidence, prima facie evidence of Roman silver mining or processing. In fact, and there are no mines. What you're left with is the fact that, I have to say this, that precious minerals seduce people. They always have, and they always will. Even geologists, even big companies. So everybody wants to find a bit of Roman silver, and there's no doubt they used it. And there's no doubt they used a lot of lead. But the evidence is this. Geologically, at least, most of the North Pennines is silver poor. It's got less than 8 ounces of silver per tonne of lead metal.
I'll keep this.
And I thought when you went, I thought, God, have I made a mistake? So these little blobs, there's Epiacum up the top, can you see? And this is Tyne Head down here. Gadigal is there. It does exist. And these little blobs are the percentage of ounces of silver in lead metal. The majority of the North Pennine Orfield, which stretches from, say, Weardale northwards, is silver poor. 8 ounces of silver per tonne of lead metal. Why do we know that? Well, because they mined, I've forgotten how many millions of tonnes of lead in the 18th, 19th and early 20th centuries. And that was the average. They had all their lead assayed, and that was the average. However, there are 3 mines that have a slightly boosted silver level, about 40 ounces per tonne. So it's in Sir John's mine, and that's it. If you ever want to go and have a look it was a pretty poor lead mine, to be honest, but it had a high silver value. Not that they took anything out of it. And Clargill Head, and there's another one up here. This is the road going over to Durham. So the rest of it, so geologically, most geologists think that the Romans did not exploit silver up here. They think it's plausible, but they don't think it's probable or likely. It's not to say it didn't happen. Now, on the other hand, if I'm going to balance this out, the historians and the archaeologists will say, but, in the 12th century, there are records of people having to pay huge taxes for the amount of silver they took out of mines in this area. And you will find, not parish records, but records that show that's the case, that they were paying a lot of tax on silver. But those records are for the 12th century, and they're a written record, but they're unverifiable. And they set against, if you like, the scientific geological data that doesn't believe that. The other point that people will make is that, why are these things silver rich? You've got to explain why these are silver rich and not everywhere else is. And the possibility is that they've been enriched by groundwaters concentrating the silver content. You've also got to answer the question of why there's no desilvering or cupellation evidence. It's called cupellation when you make lead and then you take the silver out of lead. And there's a reason why they would take silver out of lead. It is alleged that silver in lead makes it less workable and malleable. So to take it out is a good thing. But I've not read an academic paper in a metallurgical journal that, I may be just missing it, but I haven't read it. The other point that's often made is, because geologists will also tell you, look, simple mineral economics means 8 ounces a tonne is just not worth the effort. You do not want the labour. To which those who are in favour of, yes, they did mine silver and extract it, it will say, mineral economics don't work. Labour was free. They had to make work for your soldiers. You possibly got slaves and prisoners. Keep them busy, even if it's only 8 ounces of silver. Entirely plausible, but please don't use it as a reason to say the Romans mined silver. The balanced argument is, scientifically and geologically, it doesn't stack up. Historically, there are things in its favour, and that's pretty much, I think, where it lies at the moment. And it's really difficult to crack this nut, because even the lead mining, I know that Damien's at the back who's doing his DPhil in this very subject. Even trying to prove they mined lead here is difficult. So when they're now using incredibly sophisticated things like taking cores from peat bogs to look at the levels of lead in the atmosphere in Roman times and before and afterwards. The difficulty with that is, it's a bit like taking pollen samples to know what the vegetation was. You don't know what the context of, how far away that polluted, contaminated air was coming from, or where. And so I know one of the things that Damien's doing, I think, is to explore some of the peat bogs around here to see whether there's any proxies, whether there are any indicators for that. So this is a real it's a hot topic for me, but then I'm a nerd. So but the whole subject of what did they mine here? There are ingots of lead, they're called pigs, that they find in Yorkshire, but none have been found to my knowledge here. There are seals that have the name metal on it, and metal is mine in Latin, and some of them have XARG. Now you could say XARG, argentiferous is silver, you know, argent, silver. XARG, does it mean we've removed the silver, XARG, or does it mean from the silver mines? And the other thing about these so-called lead seals is they're not all lead, all the bit of tin as well, so when you get to it, so they were found in Brough. And there's lots of piecemeal evidence. As you can see, I get carried away about this because it's a real good detective story. But it would be nice to be able to put it on a more reliable scientific footing, rather than what you might call poetic license. So, that's it. With that contentious statement, that's it. Thank you. That's very kind of you, thank you.